The RayDrop is a microfluidic droplet generator chip developed and manufactured by Secoya Technologies. Its specific design allows for multiple liquid emulsification within the same device with no coating needed. The RayDrop is composed of 3 fully removable parts, 2 inserts on each side, a center section containing a nozzle, and an outlet capillary. Using the RayDrop, droplet sizes are generated from 20 micrometers to 450 micrometers diameter. Production frequency goes up to 10,000 Hz for both water and oil and water droplets. The flexibility of this chip comes from the availability of a wide set of inserts including different nozzle and capillary sizes. This allows the device to be customized for a number of applications. Along with intuitive use, no coating requirements, quick cleaning, and user-friendly insert changes, the RayDrop generates droplets with high monodispersity. There are 4 standard microfluidic connections, 2 on the body for the continuous phase, 1 on each insert for the dispersed phase entry, and 1 on the collecting emulsion outlet. The RayDrop's unique design allows for co-flow focusing of the different phases to generate monodispersed droplets. Droplet generation can be used to encapsulate either lipophilic or hydrophilic therapeutics compounds, allowing for various applications such as drug testing on single-cell or microparticle generation. In droplet production for drug release and delivery, controlled particle size is important. The droplet size is directly related to its degradation rate and the drug release rate. Flow rate stability is critical for having repeatable particle volume drug delivery. Syringe pumps are commonly used for generating droplets in microfluidic experiments, but provide limited flow control. As a consequence, the droplet size is affected. An alternative to syringe pumps are pressure-based flow controllers. These show high precision flow control and high reaction time while keeping flow monitoring possible. Controlling droplet production rate and size has always been a strong drawback. Several models were developed in order to efficiently predict those parameters. Fluigent developed a droplet size calculator based on the geometry of the RayDrop. Users can estimate droplet sizes based on measurements obtained from numerical modeling to help predict the diameter. The estimation accounts for the RayDrop's nozzle diameter, flow rate of the continuous phase, viscosities of both phases, and interfacial tension. Here is a quick example of how to use this tool. We want to generate water in desurf droplets. We input the parameters as followed. At this set of parameters, we can see the droplet size is 150 micrometers for a production frequency of 94 Hz. Let's modify the flow rates. We decrease the size down to 110 micrometers and increase the production rate up to 239 Hz. Find additional expertise and resources about microfluidic droplet and emulsions at www.fluigent.com.